Section 2.5 deals with solving inequalities with variables on both sides. Much like solving equations with variables on both sides, we're going to follow the same big ideas in conjunction with our main properties dealing with inequalities. So please take a minute and complete the 5 warm-up problems. All right, so let's check our solutions here. Number 1, we had variables on both sides, and we like to choose the side with a greater number of variables to avoid negatives. So in this case, that was the right-hand side. So if we subtract 2x from both sides, we end up with 0 equals 5x plus 15. We then move that 15 over and eventually solve for x, where x is equal to negative 3. Number 2, we had variables on both sides as well. The left side would be the side with a larger number. So we bring the 2y over by adding 2y since it was being subtracted. So we end up with y equals 5. In number 3, we had to distribute first. Then we had variables on both sides. The larger side would be the left side. So we needed to add 2z to both sides. Z equals negative 1. In number 4, it was a very good problem reminding you that sometimes you're going to run into situations that you're going to have no solution or infinite solutions. So we end up with 3p minus 3 equals 3p plus 2 once we distribute. Whenever you have the same number of p's or variables, whatever, on each side, be wary because you're likely going to end up with a special circumstance. So in this case, once we subtract 3p from both sides in the solving process, we end up with negative 3 equals 2, and that's clearly not a true statement. So this is a no solution problem. And then looking at number 5, we needed to distribute the 5 in there. So we have 10 minus 5b is greater than 52. So we need to isolate a variable on the left-hand side. So we end up with then negative 5b is greater than 42. Through solving, we need to divide both sides by negative 5. And whenever we multiply or divide both sides of an inequality, we must flip our inequality symbol. So our answer ended up b is less than negative 8.4. All right, so today's lesson, our goal is to be able to solve inequalities that contain variable terms on both sides. Okay, so just like equations, some inequalities will have variables on both sides. And we solve these simply by collecting all of our variables on one side. We use our inverse operations in order to do so. And especially due to the fact that negatives bring in an extra step in terms of inequalities, this is why it's super important to bring your variables to the side with the larger number of variables. Then we just want to make sure we keep everything in line from there, and maybe we may need to flip our solution at the very end. So number 1 is a perfect example of this. If I look at number 1, I have y is less than or equal to 4y plus 18. Now I've got my dotted line through my inequality symbol, and I've got y's on both sides. Now if I compare y versus 4y, obviously 4y is bigger. So I'm going to subtract y from both sides. Now because there's nothing left on the left, we have 0. Is less than or equal to 3y plus 18. We're now committed to solving for y on the right-hand side. So that means I need to move the 18 by subtracting 18 from both sides, which leaves us with negative 18 is less than or equal to 3y. And now we get y fully alone by dividing both sides by 3. And we're keeping everything in its lane. So we have negative 6 is less than or equal to y. And now we'll write the final answer with y first, which would mean y is greater than or equal to negative 6. So we're flipping the whole thing around, keeping our inequality still open to the y. So if I've got negative 10, negative 8, negative 6, negative 4, negative 2, 0. We do need appropriate numbers on our number lines. So we would have a closed circle on negative 6, and we're going to shade to the right. It's greater than, and our inequality symbol is pointing to the right. Now I'm going to show you what happens if we were to solve for y on the left-hand side. and it works, but we just have to be super careful. If I have y is less than or equal to 4y plus 18, if I decide, well, let me just move all my variables to the left, because that's what some people are insistent on doing, we would subtract 4y from both sides, and now we've got negative 3y is less than or equal to 18. We would now divide both sides by negative 3, and here's the problem. People often forget to flip our inequality symbol. So because we're dividing both sides by a negative, we've got to flip. So we end up with y is greater than or equal to negative 6. Now in this case, it was an extra step or so in order to do it the way that I choose, but I avoid the possibility of potentially forgetting to flip that inequality by always choosing the side with the larger number. So let's take a look at number 2. Number 2, we've got variables on both sides of our inequality. In this particular case, the 4m is bigger than the 2m, so we want everything on the left. So if I subtract 2m from both sides, I now have 2m minus 3 is less than 6. Next, I want to get 2m alone on the left, so I'm adding 3 to both sides. Leaves me with 2m is less than 9. And now to get m completely by itself, we divide both sides by 2. Now we often like nice simplified fractions in algebra, but when we have a nice decimal like this, it's okay to use m is less than 4.5 because it will help you with your graphing of your solution. So I need to go halfway between 4 and 5, so we can kind of do a skip. So 4, skip 1, 5, skip 1, 6, skip 1, 7. Let's backtrack. So we're going to have an open circle on 4.5 and shade to the left. Bad little arrow there. There's another bad arrow. All right, so what I would like you to do now is I would like you to do numbers 3 and 4. Okay, we know all of our big ideas for this particular lesson. Number 3 is exactly like number 1. Okay, we have variables on both sides, smaller sides on the left. So you need to choose. Do I want to go with Ms. Snyder's method, select the side with the bigger number of variables, or do I always want to select the left? But then I've got to be careful with the negatives. So use number 1 as a model for number 3. And then number 4 is pretty much exactly like number 2. Variables on both sides, the left side has the bigger number. All right, so here are your solutions. Okay, I chose my method where I just like to keep my variables on the side with the larger number to avoid negatives and just keep everything in its slot until the very end. So I ended up with negative 2 is greater than or equal to x, which means that x is less than or equal to negative 2. Close circle, shade to the left. And then number 4, the variables need to be on the left-hand side no matter what here, because 5t is bigger than our negative 2t. We end up with t is less than negative 1. Open circle on negative 1, shade to the left. All right, we've got a couple word problems here. Number 5 says the home cleaning company charges $312 to power wash the siding of a house, plus $12 for each window. Power Clean charges $36 per window, and the price includes power washing the siding. We've got two different situations. Let's kind of highlight. How many windows must a house have to make the total cost for the home cleaning company less expensive than Power Clean? So we've got our two different scenarios here. Home cleaning company's cost is broken down using two pieces of information. So home cleaning company, they charge a flat fee of $312 plus $12 for each window, or $12 per window. So that would be plus 12W, where W equals number of windows. Then Power Clean just straight up charges $36 per window. So their price is calculated by 36 times W. First of all, let's let W equal number of windows. And now let's set up an inequality here to satisfy the situation. So it says, how many windows must a house have to make the total cost from home cleaning company less expensive than Power Clean? So let's just start by writing, literally, we want HCC to be less than Power Clean. So now we're just going to take each of their expressions that represents their cost and substitute it in and then solve. So we have 312 plus 12W is HCC. We want it to be less than Power Clean, which is just 36W. So this is a case where we have variables on both sides. Therefore, we want to choose the side with a larger number, and that's the right in this case. So that means I'm going to subtract 12W from both sides, which leaves me with 312 is less than 24W. And we want to make sure we get our math right here when we're going to divide both sides now by 24 to solve for W on the right. 312 divided by 24 is 13. So keeping everything in line, 13 is less than W, which therefore means W is greater than 13. Okay, so this is a situation where we need to make sure that we right express our solution in an appropriate manner. So for this, how many windows must a house have in order to make that cost be less? Well, if W needs to be greater than 13, that means we got to bump that up to 14. So 14 windows or more. Order for the home cleaning company to cost less than Power Clean. Okay, because windows obviously are going to be counted in whole windows, not half windows. All right, so number 6 is the same exact idea. You're definitely going to need a calculator because there's decimals, but let's lay it out and then you're going to do this problem. Okay, so it says A plus advertising charges $24 plus 10 cents per flyer. Then it says Print and More charges just 25 cents per flyer. For how many flyers is the cost of A plus less than the cost of Print and More? Okay, so once again, number 6 is exactly like number 5. I want you to lay out each expression to represent the cost of A plus and the cost of Print and More. We want to define our variable, identify the big idea, which we want to be more or less expensive, substitute in and solve. So give it a whirl using number 5 as your model. Right, so taking a look at our solution here, A plus is 24 plus 10 cents per flyer, so 10 cents, 0.1 times X. Print and More is just 25 cents per flyer, so 0.25X, where X is the number of flyers. I just don't like using the variable F. So we want the big idea for A plus to be less than Print and More. So A plus is less than Print and More. So we substitute our expressions in and we go ahead and solve. So we end up with 160 is less than X, therefore X is greater than 160. So the cost of A plus is less than Print and More for more than 160 flyers, which would be 161 or more flyers. So we've got two more big ideas here that we need to address in this particular lesson. And the first one deals with sometimes we need to simplify one or both sides of an inequality before solving it, just like when we're solving equations. So we may need to use the distributive property. We may need to just simply combine like terms. So we're going to jump right into here, number 7. Flip my screen around. So in number 7, I do have a distributive property right here in front of my face. Got that 2 on the outside of the parentheses that I need to distribute in. So I've got 2 times k and 2 times negative 3. So that's going to leave me with 2k minus 2 times 3 is 6 is greater than. Now, when I have like terms on one side of the equation, I'm going to put them together. We're not going to use inverse operations. I'm just going to put them together. So the 6 and the negative 3 are like terms. So 6 minus 3 is 3. So now the right side of the equation says 3k plus 3. So we distributed on the left, and then on the right-hand side, we had some like terms to just clean up. So now when I look at the left and the right, I've got variables on both sides. Everything's completely cleaned. The right side is bigger than the left in terms of the variables. So I'm going to subtract 2k from the left and from the right in order to avoid those negatives. So that leaves me with negative 6 is greater than k plus 3. Get k completely alone by subtracting 3 from both sides. So we have negative 9 is greater than k, which therefore means that k is less than 9, or k is less than negative 9. My puppy here is being a little monster. Okay, so we need negative 9 needs to be our target number on the number line. We've got an open circle there, and we are shading to the left. Let's move on, and we'll do number 10, and then you'll do 8 and 9 individually. So when I look at number 10, I've got 0.5x minus 0.3 plus 1.9x is less than 0.3x plus 6. So when I look at this, I'm like, I've got a lot going on here on the left-hand side. We've got some like terms. So they're going to come together just by combining them. We're not using inverse operations. So 0.5x plus 1.9x going to give me 2.4x. Drag down that minus 0.3 is less than 0.3x plus 6. So now we can go about our business. We've got variables on both sides now that everything is cleaned up on the left. And I'm going to select to put my variables on the left side because 2.4x is bigger than 0.3x. So if I subtract 0.3x from both sides, it's going to give me 2.1x minus 0.3 is less than 6. We want to isolate the variable terms, so now we're going to add 0.3 to both sides. So 2.1x is less than 6.3. And now we get x completely alone. We undo that multiplication by division. So we're dividing both sides by 2.1. So x is less than 3. Okay, so 0 is our target number, or I'm sorry, 3 is our target number. 0, 1, 2, 3. Sometimes it's simple enough to put every number. Other times you run into too many negatives. and it's hard to fit the numbers on, but we need to make sure that we do have appropriate numbers on our number line for reference points. So we've got an open circle on 3 and shade to the left. We have a lot of less thans here today. All right, so I would like you to complete numbers 8 and 9. Okay, 8 is just a multi-step inequality. 9, we've got some distributive property first. All right, so let's check some answers here. In number 8, we choose to put our variables on the left-hand side. So y is greater than or equal to -1. Closed circle on the -1, shade to the right. In number 9, we needed to distribute on both sides. It resulted in 10 minus 5r is greater than or equal to 3r minus 6. Technically, 3r is bigger than -5r, so we're going to add 5r to both sides in order to avoid negatives. And again, if you choose to put everything on the left, that's fine as long as you're very careful. You'll get the same answer at the end. So then we're going to add 6 to both sides, divide by 8. So we get 2 is greater than or equal to r, which would therefore mean that r is less than or equal to 2. So close circle on 2, shade to the left. All right, I'm going to wrap up here with a couple problems that are addressing the situation that sometimes you're going to have inequalities that are either always true or always false, no matter what. Okay, so basically, we address this in our solving equations. If both of our sides of an inequality are fully simplified, and we have the same variable term, the same number of x's or y's, or whatever the variable is on both the left and the right, we're going to run into a certain special circumstance, and we just have to determine whether it's going to be an all real numbers situation or a no solution situation. Okay, so if I look at number 11, I've got 2x minus 7 is less than or equal to 5 plus 2x. Now, if we think about literally trying to bring the x's together, we would say, well, I'd have to subtract 2x from both the left and the right in order to try to collect them, and they're canceling each other out on both sides. So all we have left is -7 is less than or equal to 5. Now, is that a true statement? Yes, -7 is always less than or equal to 5. So this is going to be all real numbers or infinite solutions. So literally the whole entire number line is shaded. Next, I'm going to look at number 12, I guess. So if we've got 2 times the quantity 3y minus 2, minus 4 is greater than or equal to 3 times the quantity 2y plus 7. On the surface, it doesn't look like anything special other than a lot of work. So we're going to start by distributing our 2. So we've got 2 times 3y is going to give us 6y. 2 times -2 is minus 4. Drag down the minus 4, greater than or equal to, we're distributing now the 3. So 3 times 2y is going to give us 6y. 3 times 7 is positive 21. So I do have some like terms yet here on the left. I've got a -4 minus 4. So that's going to give me -8 because, again, no inverse operations if they're on the same sides. 6y minus 8 is greater than or equal to 6y plus 21. Well, again, we've got the same number of y's on both sides, so we're going to run into something special here. So if we think about trying to collect them, like we would subtract 6y from both sides, and they all go away. So now we have -8 is greater than or equal to 21. Now, if we think about whether or not this is a true statement, there's noises outside the house right now, so my dog is going nuts again. So we ask ourselves, is this a true statement? Is -8 greater than or equal to 21? No, that is not a true statement. That's false. So this is no solution. What I'd like you to do now is 13 and 14. They're also going to be special circumstances. Use 11 and 12 as a model. All right, so upon distributing in number 13, we end up with 4y minus 4 is greater than or equal to 4y plus 2. If we try to collect those 4y's, we'd be subtracting 4y from both sides, so all the y's go away. We've got negative 4 is greater than or equal to 2. That is not true, so this one's no solutions. And then number 14, x minus 2 is less than x plus 1. Subtract x from both sides to try to collect them, cancels everywhere, so we end up with negative 2 is less than 1. That is a true statement, so all real numbers are infinite solutions here for 14.